I do have one review handout that you're going to get today if you want to get a jump start on practicing. We're looking here at, this is called transformations of sine and cosine functions. And all we're doing is we're extending what we did yesterday. Yesterday we looked at the parameters a and b. Today what we're going to do is look at the parameters h and k. You will notice, if you are observant, that nowhere on the screen does it say h and k. So we have a little bit of a change in the letters we use, and we'll talk about that just to begin with. The bottom line is we are going to be looking today at applying all of the transformations that we are aware of, whether they are vertical stretches, vertical reflections, horizontal stretches, horizontal reflections, horizontal translations, left and right, or left or right, vertical translations up or down. We will never look in our lessons at inverses of trig functions. We will never look in our lessons at square roots of trig functions, but that doesn't mean that you might not see that on an exam. Okay? And when we do a bit of review on Monday, I will go through what those graphs would look like. However, if we take y equals f of x and transform it using that template, this template on the top right corner of your screen is from your formula sheet, right? And I think most of us just know it. I don't think we really need to refer to the formula sheet very often, but there it is. If you apply that to sine of x, then we're going to have to put a times f of b bracket x minus h. Well, f is sine, so you end up with sine of b brackets x minus h. Remember this f up here in the general statement, I'll highlight it just for anybody watching this on video. This f refers to whatever the function operation is. So if it's f of x equals sine x, then sine is f. And if we do the same thing with cosine, of course, you're going to get this. However, instead of using h, we use c, and instead of using k, we use d. Now, there might be a number of reasons for it. I think the primary reason is when we talk about trigonometry, the letter k is for period. So I think somebody has decided somewhere along the line that what we're going to do is use not these two, if you look at the screen right now, not these two, but these two instead. Yeah.
So then what is the point of having h and k to begin with? Why can't we just have
I don't know. What's the point of using p and q last year in Math 20? I don't know the philosophy behind it. I can rationalize it after the fact and say maybe it's good in just getting you used to using different letters and being adaptable to different situations. And I'll give you a specific example here of what I mean by adaptable. You're going to see quite frequently on exams, particularly the diploma exam, things where we decide to put the letter C here and the letter R here, like we just put whatever parameter letters or labels we want. I want to show something to you because you've just triggered my memory in terms of something. There is a question in your review package that I made up. I'll show it to you right here, where I tell you that you have this trigonometric function, and if you take a look at the equation of the function there, I've changed something slightly, haven't I? What's different compared to what I just told you and what's in your notes right now? How is this function at the top of the page different? It's minus d. And it turns out that when you use the template that we're going to talk about in this question, d is a negative number. But I put minus d because I want you to record the amount of the number. So it's a matter of adaptability. I agree. And the other day I found myself teaching in quadratic functions in my Math 20 class, talking about h and k for 5 minutes, and everybody's just staring at me like I've lost my mind. And then I realized, oh, wait a minute, you're used to p and q. So we had the same discussion there that we're having now. Okay. So anyway, we use these. And these, by the way, These, by the way, are on your formula sheet. If you look on your formula sheet, they're on there. I'll just show you where they are so that you're accustomed to seeing them. I don't want you looking at it later and going, oh, I didn't know they were there, or looking at it later and going, what is that? So on your formula sheet, these are at the very bottom right-hand corner of your formula sheet, if you ever need to refer to them. So I think the rationale here is we give them to you in addition to this thing precisely because they have different letters. All right. Everything that we have learned about A, B, H, and K is still true about A, B, C, and D. Okay? So whatever H did, C does. Whatever K did, D does. We learned yesterday that the amplitude, of course, is found by looking at the parameter A. It's the absolute value of A. We learned that the period is connected to the absolute value of B. We use the absolute value here in that period statement because a period is always an amount. It's never a negative number. So if B is negative, you don't want to figure out the period as a negative. There's a horizontal translation of C units. So in the past, what this would have said is there's a horizontal translation of H units. And when H is positive, it shifts in a positive direction. When H is negative, it shifts in a negative direction. Well, it's just C. There is, however, a change of terminology here. This has a specific name. It's called a phase shift. And when you're talking in trigonometry about a phase shift, it means horizontal. So if you were asked on an exam, what is the phase shift, you were asked for the value of C. And unlike H, if H is negative 5, then we would say the function shifts 5 to the left. And I've taught you not to say things like there's a horizontal shift of negative 5 units. I think that's lazy or sloppy. But we do that with trig. We talk about negative phase shifts. If I say the phase shift of the function is negative pi over 2 radians, that means we take the original function and shift it to the left pi over 2. So it's okay to use the negative in the phase shift. Whatever K did before is what D does now. So D is responsible for a vertical translation, and it's down if D is negative, and it's up if D is positive. A little note here for you. We also have a special name or, good morning. We also have a special name or a term or way of saying what the vertical shift or translation is. And we say it's a vertical displacement. We actually use the word vertical in there. This is on page 30 of our handout. The order of the transformations in terms of applying them to functions and to graphs is that you have to apply A and B first, and then C and D, because in the past we've learned that A and B comes before H and K. But we're just using C and D. And I'm going to, after a while, probably starting now, I'm going to stop saying we used to do this with H, we used to do this with K. So use your knowledge of transformations to sketch the graphs of the following functions and complete the information below. Now, in drawing these graphs, we're going to make use of drawing horizontal guidelines. I should have handed these out earlier. You don't have to use a ruler, but I'm just going to hand out rulers so that if you want your notes to be very tidy. Can I take this?
Yeah.
Thank you. If you want your notes to be very tidy, did I give you one? Then you can use a ruler. Can you pass one over to the right? Can you pass one over to the right? Can you pass one over to the right, please?
Thank you.
All right, you're welcome. So I'm not going to go through a lot of written explanation with this because, quite frankly, most of it is things you should be able to do anyway. You know that the center, and hold off on drawing anything yet, okay? you know that the center of a cosine function is the x-axis, and a cosine function would normally have a maximum value of 1 and a minimum value of -1, right? And you're not drawing this, I'm just talking about the cosine function. But since a here is -3/5, what that means is that the maximum will only be at 3/5 and the minimum will only be at -3/5. Here's the important thing I want you to notice though. Forget about where the maximum is specifically. Because the amplitude is 3/5, the maximum has to be 3/5 above the middle. It has to be 3/5 above the middle. I know the middle is at 0, okay? But since d is 1, what that does, and I'm just going to get rid of, just for a moment, the maximum and minimum guidelines. Because d is 1, whatever happens stretch-wise or reflection-wise, the bottom line is at the end, the whole thing is going to be translated up 1. Which means the middle of this graph, after all is said and done, is going to be up at +1. It's important for you to note that d, which is the vertical displacement, will always be the central vertical location of the graph. And since the amplitude is 3/5, the maximum will be 3/5 above that, and the minimum will be 3/5 below that. Okay? So I'm setting up my guidelines here. Now, I'm going to go back in time again here. Don't worry about drawing this because I've asked you to draw this. I'm going to do something that I don't want you to change. If we go back to sine, or cosine I suppose it is, cosine would normally start at 1, right? But I don't want you to think of cosine starting at 1. I want you to think of cosine starting at the top, okay? Cosine normally starts at the top and goes down. Okay? Because a is negative, cosine would then start at the bottom going up. All right? So that's what we've discovered. Cosine is going to start at the bottom going up. If we shift the whole thing up with that idea in mind, I go back to this situation, what that means is that cosine is going to start at the bottom going up. It's like we're imagining, this isn't the case, but it's like we're imagining that this is the origin. And we're drawing a graph with the right amplitude, starting in the right place, going in the right direction. The only other thing we need to do to complete this is to say that since b is 1, the period is 2 pi. By the way, there is no c here. It's not x minus something. Since b is 1, the period is 2 pi, and what that means is the graph is going to start at this red point going up, and it has to go up, up, down, down. It has to complete one full cycle and return to that location. And again, what we did, and I feel as though for some reason I didn't do that great of a job yesterday explaining this. What you do is visually take the distance between those 2 points, which is one period, and you chop it into 4 pieces. Okay? So if I do that, and I'm just going to do it down here, if I chop this into 4 pieces, I can cut it in half here, and I can cut each of these in a half here. And that tells me that this is going to go up to the midpoint, mid-vertical location, continue up to the maximum, go down to the mid-vertical location, and then continue down to the minimum. So what it's going to look like is curve up, curve down, curve down, curve up. And you know, again, there's an arrowhead on the end of this. If you want to write another one or draw another one on the other side, that's fine. And you may very well on an exam be asked to do so. It might say draw 2 or 3 or 4 complete periods of the graph. What is the domain? Well, yesterday we learned that the domain of this cannot be changed. You cannot do anything to these functions. They will always go forever in both directions horizontally. The range yesterday, we said yesterday that the range was the negative of the amplitude to the positive of the amplitude. But that's only because yesterday all the functions were centered at y equals 0. Here, the minimum value is negative 2/5. The maximum value up here is 1 3/5, which is 8/5. Not negative 2/5. Lost my mind there for a second. 2/5. Goes from 2/5 to 8/5. So 2/5 is less than or equal to y, which is less than or equal to 8/5. It's a little difficult to see with these numbers, but this will always be d minus the amplitude to this will always be d plus the amplitude. I mean, think about what the amplitude is, which is the absolute value of a, lowercase a. It's how far above the middle of the graph you go. So if d is at, what was my d at? 1? If d is at 1, the maximum will be the amplitude higher than that. So I go 1, which is d, plus the amplitude to get the maximum. If d is at 1, then the graph is going to go the amplitude below that. So the minimum will be a, the amplitude, the amplitude, I'll just say the amplitude, taken away from d. The order in which you subtract these is important. You can't go amplitude minus d. The amplitude, by the way, is 3/5. The amplitude and the period you should be able to determine based on what we talked about yesterday. It's got nothing whatsoever to do with what we're learning today. Any questions with that graph? All right, let's try another one. Well, here, what do we have? Let's make a list this time out of the gate of A, B, C, and D. And I was so close there to saying A, B, H, and K. And you know, if you do, that's okay. I mean, if you just want to stick with H and K, that's fine, but be prepared to use C and D on written response. A is 1. Okay, the amplitude is 1. That's going to be helpful to us. B is 1/2. That means the period is 4 pi, and I want everybody to ruminate on that right now. Think about that. If B is 1/2, the period is 4 pi. And I'm going to ask the same question I asked yesterday. How many of you arrived at 4 pi by thinking of a stretch by a factor of 2? How many of you go 2 pi over 1/2? That's good. I would like to see more and more of you doing that rather than thinking of stretches. So we use this little tiny formula, which unfortunately we have to remember. 2 pi over b, it's the absolute value of b, which means 2 pi over 1/2. You multiply the top and the bottom of this by 2. The 2's cancel and you're left with 4 pi. I'm going to erase that, so if you feel the need to write it down, but I'm going to erase it in a second. D is negative 1/2. Well, that simply means that the middle of the graph is at negative 1/2, right? That's what it means. And by the way, C is 0. And I'm leaving C out of it because as soon as C makes its appearance, things get complicated, okay? Well, now what we're going to do is use the fact that the middle of the graph is at D, which is negative 1/2, and the amplitude is 1, which tells us the maximum will be 1 above and the minimum will be 1 below. This A and D together, setting up those grid lines, is absolutely vital to understanding what the graphs will look like. So this distance here, and I'm probably going to erase this in a second, but this is the amplitude, or this is the amplitude. Of course, where that brown line is the middle of the graph, which is d, negative 1/2. Which means we could actually answer what the range is right now. It's negative, we have to look at this graph, it's negative 1.5. Oh, I'm going to go decimals this time. Is less than or equal to y, which is less than or equal to 0.5. I want you to notice that this number here, that I'm underlining in red, is what you get if you take d minus the amplitude. D is negative 0.5. If I subtract the amplitude of 1, I get negative 1.5. This number here, the maximum that I'm going to underline in green, is what you get if you take d, which is negative 1/2, negative 0.5, and you add the amplitude of 1. Domain, before we even sketch this, domain is any real number. So now let's talk about where this thing starts. Well, sine starts at the origin going up, but we make our thinking a little more general and say, forget about the origin. Sine starts in the middle going up. This is weird. I know it's weird because we've already shifted everything before we've applied any other transformations, but that doesn't matter. It's going to start here going up. And since b is 1/2, it's going to repeat every 4 pi, so it has to go up from this point to the top, down to the middle, down to the bottom, and back to the middle in one period. So you're using A and D to set up the vertical kind of guide to graphing this, and you're using the period to set up the horizontal guide to graphing it. Now we break this into 4 pieces. Of course, if it's sine, I want to go back up here. If it's sine, then the dots look like that, right? If it's cosine, you'll either go up, up, down, down, or down, down, up, up. But if it's sine, it's up, down, up, or down, up, down. You need to kind of sort that out. So we're just going to connect these and we will be done. Again, if you choose to sketch another one to the left of that, feel free. I think you know how. I don't think that's a difficult task. You're just going to continue to go down. You will go down to here, then you will go up to here, then you will go down up to there, and then down to here. You're just thinking in the opposite direction. Or if you're a real good visual thinker, you're doing that, right? You're just kind of repeating the process over and over again. All right, now we've got a c involved. So y is equal to -7. Well, that means a is -7. It's a cosine function. B is equal to 3. C, I just want to walk away from for a minute, and D is equal to -4. Would you agree on A, B, and D? What is C? I want you to think about what C is and write down what C is. Well, you can't make the same mistake that you might have been making in Unit 1. Hopefully you've corrected it. C is not pi. What is it? Miles?
Pi divided by 2/3.
Pi divided by 3. Good. Because you have to factor out b, which is 3, and you're left with x minus pi over 3, and then -4. Right, if you look at your formula sheet, or if you look, well, I'll go to my formula sheet because it's easier for me right now. If you go to your formula sheet and you look at the template for y equals a cos of, etc., there's a b and then there's brackets x minus c. So you need to factor that 3 out. And when you factor out, you divide. So we end up with a b value of pi over 3. A c value of pi over 3. So what are we going to do here? Well, the vertical displacement is negative 4. We can put in that guideline. The amplitude is 7. The amplitude is 7 because a is negative 7, little a is negative 7, big A is the absolute value of little a, the absolute value of negative 7 is positive 7. The amplitude is 7. So we have to go 7 above and 7 below that, which means, by the way, without even looking at my graph, looking at the range, I can say that y will be between or equal to whatever negative 4 plus 7 is as a maximum, and whatever negative 4 minus 7 is, which is negative 11 for a minimum. You ought to be able to come up with the range without necessarily sketching those lines or a graph. And sure as shooting, if we go 7 above, we are at positive 3. If we go 7 below, we are at negative 11. And I would really hope that at this level, you don't need to count squares to know where you're going to land by adding 7. Okay, now let's deal with the period. What's the period? Well, since b is 3, the period will be 2 pi over b, which is 2 pi over 3. And we're going to come back to that, but we're going to need to know it in a minute. And the domain is any real number. So now it's all from here, finding the right start point and then using the period to draw 4 pieces. So where does cosine normally start? Well, it normally starts at 1, but to make it more general, it starts at the top. And it starts at the top going down. So you can decide whether you want to draw this little detail if you want, but you don't need to. If it were just 7 cosine, that would be the nature of where it starts and which way it goes. But it's negative 7, which means before we shifted it up, it reflected, and that means that now we are saying, well, no, it's got to start at the bottom going up. However, there's a phase shift. So normally then the start point would be at the bottom going up, but because the phase shift is pi over 3, this is the phase shift. Since the phase shift is pi over 3, it's going to start here going up. So now what we have to do is from that green point, again, this is where it would start up top if A were positive and there were no phase shift. The red line at the bottom is where it would start if A was negative and there's no phase shift, but there's a phase shift of pi over 3 to the right. The period is 2 pi over 3. So we have to draw from this green point up, up, down, down, and do that in 2 pi over 3. Well, this is 2 pi over 3 right here. It's 4 squares. So that's what we need to do. We need to return to that point here. We have to go up, up, down, down. It's going to be a very, very narrow graph based on the scale. So you break this into 4 chunks. In the middle, it's going to find its way at the top. Halfway between the top and the bottom, it will be in the middle vertically, and halfway again between the top and the bottom, it will be halfway vertically. So what you have to draw, I'm just going to get rid of a few things here to give us room, is you need to draw a curve that goes up, continues up, curves down, and continues down. And feel free to draw a whole bunch of those if you like. All right. The graph shows a cosine function in the form y equals a cos of bx. We could have done this one yesterday because there's no c and d. But I didn't want to pack too much in yesterday. The problem here, everybody, well, there's a number of problems. One is these x coordinates are numbers that are not in terms of pi, but they're still radians. It doesn't say 12 degrees. It says 12. So it's still radians. What we need to do from this information is determine A, B, C, and D. Well, first of all, D is 0 and C is 0. Would you agree? Because it says up here, y equals A cos of bx. There is no C and D. So how are we going to determine A? Well, A is the amplitude. I would like everybody to think about the numbers given on that graph. Again, the difficult part as well is there's no grid to look at. It's just numbers. I want you to see if you can figure out what the amplitude is. Aiden, do you know what the amplitude is? 7. It is 7. We can see visually, and I don't know that you need to do this, but this is the maximum, this is the minimum. And we know, I mean visually it's pretty easy to see this, we know that the middle is halfway in between, and since the maximum is at 7 and the minimum is at -7, the middle is at 0, so you can see the amplitude is 7. If the amplitude is 7, that means A is 7. But can A be 7 to give us this graph if C and D are both 0? Why not, Allie?
Has to be negative.
Has to be negative because this is a cosine function. The start point of cosine if A were positive 7 would be at the top going down. But this starts at the bottom going up, and that tells us that A is -7. Now we need to figure out what B is, and then we have an answer to the question. Well, B is 2 pi over the period. So I want everybody to figure out what the period of this is. And that, I think, requires more thought than figuring out what the amplitude is. I'm not asking you to find B, I'm asking you to find the period, which is how far horizontally does it take to go through one complete cycle. Patrick, have you got it?
12.
Excellent. Can you explain why it's 12? And there's a couple of ways to do it.
Yeah, from 12 to 18, it's like half of the rotation.
Can I stop you there? Perfect. And that's the best way to think. Okay, there's another way that will work in this question that doesn't always work. What Patrick is recognizing is that from this point up to that point is only half of the period. And this is going from x equals 12 to x equals 18, which is 6. So then we have to double the 6. So the period is 12, which means B is 2 pi over 12. And you can reduce the 2 over the 12 down. So this is a little weird. You have to get used to it. B this time is not just a number like 3 or 2 or 1/2. It's a multiple of pi. It's a 1/6 of pi. Which means our function is y equals A cos B times x. There is another way to determine that the period here is 12. Did anybody say it's 12 because starting here, you go up, down, down, and it takes you 12? That will work, but only because the start point is on the y-axis. If it isn't, you can't do that. All right. Number 3. Sketch this graph over 2 cycles. State the amplitude, period, phase shift, and vertical displacement. Well, you should be able to state what the amplitude is and the period is without even sketching it. In fact, I think you need to know the amplitude and the period to sketch it. The amplitude is 2, because lowercase a is negative 2. The period is 2 pi, because b is 1. Does this class end at approximately 10:07 or ish, in that area? Okay. C is negative 2 pi over 3, and D is negative 1. You know, I'm talking parameters here, so perhaps I better write the parameters for A, negative 2, and B is 1. My parameters are A is negative 2, B is 1, C is negative 2 pi over 3, D is negative 1. What this means is that the vertical displacement is negative 1, so the graph is vertically centered around y equals negative 1. If the amplitude is 2, it will go 2 above that to 1 and 2 below that to negative 3. So this question is very similar to all of the ones in 1, but I'm not asking you for the domain and range and stuff. This is a cosine graph. Cosine would normally start at the top, going down, but since a is negative, it's going to start at the bottom, going up. Okay, so it starts at the bottom, going up, but it doesn't start there going up because the phase shift is negative 2 pi over 3. We have to take that start point, because it's part of the whole graph, and shift it 2 pi over 3 to the left. So, you know, you need to do just a preliminary kind of investigation of the scale I've given you here. That distance that I put a green cloud around is pi horizontally. So 2 pi over 3 would be 2 of those squares. Okay, so that means our start point is going to be here. Going up. Now that little curve that I've got going up, that may be not drawn correctly. I'm just indicating that it goes up from there. And it's going to repeat every 2 pi because the period is 2 pi. Well, I can look up here and see quite clearly that 2 pi is 6 squares. So that means it's going to go from this red point up, up, down, down, and come back to the same place 6 squares later, which is 2 pi. And now we slice that distance between the red dots into 4 equal chunks. Halfway between, it will be at the top. Halfway between the minimum and the maximum, it will be in the middle. Halfway between the maximum and the minimum, it will be back in the middle. So this is what we are asked to draw. And we are actually asked to specifically draw this for 2 periods. So we could continue over 1.5 squares up to the middle, over 1.5 to the top. Do you see why I'm saying over 1.5 squares? Because that's how far 1/4 of the cycle is. And then over 1.5 to the bottom, and then over 1.5 to the middle, and then to the bottom. So it's going to look approximately like this. And when you're done here and you look at your picture, if it doesn't look nice and smooth, I don't know what to tell you, because you are expected to be able to graph fairly decent graphs on a written response. Any questions with 3? You'd put arrowheads on the ends of those curves, right? All right. Number 4, a graph is shown. Write an equation of the graph in the form y equals a sine b bracket x minus c plus d, where a is positive. So we are not allowed to, in this question, use a negative value of a. It has to be positive. Well, looking at this graph, I think it's always a good idea, even though A and B are applied before C and D, I think finding A and D together is one of the first things you should be looking at. You should be able to look at where this graph is vertically in terms of max and min, and determine what A is and what D is. And if you need to draw those guidelines to help you out, that's fine. Let me ask a question. How many of you see that the amplitude is 3? Okay. You don't need to draw the guidelines. How many of you see that the vertical displacement is 1? How many of you figured out the vertical displacement is 1 by figuring out that the amplitude is 3 and then going 3 above the minimum? Or 3 below the maximum? There's a lot of ways for you to do this. If that doesn't do it for you, then you need to draw in, well, I don't need to draw in, you need to imagine or potentially draw in these lines. And right away I looked at that and visually I went, no, that doesn't look right. The middle has to be halfway between the top and the bottom. So again, this number here, this is always y equals d, always. And then the amplitude is how far above. So if the amplitude is 3, A is 3, the vertical displacement is 1. Let's figure out what B is. Don't forget that B is 2 pi over the period. So we have to figure out what the period is. Well, I would probably, if I can ever make use of a point on the y-axis, I would probably use that to determine a period. So this goes up, up, down, down to that point, which means that this is the period. Well, that's, if you look at where pi is, there's 6 squares to get to pi, and that's 4 squares, so it's 4 pi over 6s, which is 2 pi over 3. The period is 2/3 pi. I'm just curious. How many of you see that B must be 3? So you don't always need to use an equation. What you could do is say, well, the period is 2 pi over B. But the period's 2 pi over 3. How on earth can you get 2 pi over 3 if it's 2 pi over B? It's if B is 3. If you use this idea here, then you have 2 pi over 2 pi over B, and you multiply the top and the bottom of this, pardon me, over 2 pi over 3, which is the period. You multiply the top and the bottom of this by 3. The 2 pi's cancel, the 3's cancel, you're left with 3 for B. Okay, now C. So I'm going to show you the first method to find C, which isn't that difficult in this question, but it becomes more difficult later. And then I'm going to show you a different way to do it. Okay? So what we can do here is the following. I am going to draw on here in green what the graph would look like if C was 0. I'm still going to use A equals 3. I'm still going to use B equals 3. I'm still going to use D equals 1. But I'm just imagining there's no phase shift. Well, this is pretty simple because it's a sine function which starts in the middle. Right? It's sine. Starts in the middle. And it would be going up. Does our graph start in the place that that green curve is drawn? No. It starts here going up. So I have to shift that green point that far to make it fit. And by the way, in explaining this on a written response, it's kind of awkward, it's difficult. But I need to shift where the graph would start with no phase shift, pi over 6 to the right, to get the graph starting where I want it to start. which means that c is pi over 6. And then we can put a, b, c, and d into that equation. And get y equals a, which is 3, sine of b, which is 3, x minus c, which is pi over 6, plus d, which is minus 1. And that's the equation. And if you put that into your calculator and set up your window settings to match this, you would discover all the points are perfect. Let me show you a different way to do it, though. That, as I said, this is fairly easy to see here. But what if the graph ended up like doing something like that and we wanted to shift it? It's not obvious how much to shift it. So what we can do instead is this. Would you agree we knew that A was 3? B was 3? We didn't know X, or we didn't know C, but we knew D was -1. Would you agree that's the case before we find C? It's a missing parameter. We're going to put in the coordinates of a point from the graph, but here's the kicker. You always need to put in a point that is either in the middle, at the top, or at the bottom. You cannot, this won't work with any other points. It will, but the algebra is beyond us. Okay? So what I'm going to do is use this point right here. Would you agree that's pi over 3 for x? And y is 4. Okay? So there's a point of pi over 3 comma 4. Just to double check, from here to here is pi. That's a third of pi right there. So I'm going to put those numbers in and get 4 just a second. Give me a second. It's not going to work in this case. Why wouldn't it work? Give me 1 second. 4, 1, 1. This is +1, isn't it? It's +1. D is 1. And I said it's not going to work, and part of my brain said that's impossible because it always works if you use a max or a min. So this is 1. What is always going to happen here is when you start rearranging, you are going to end up with sine equals either 1 or 0 all of the time. Look at what happens. I subtract 1 from both sides. I'm putting in 4 for y. 3 sine of 3 x minus c, and I'm putting in for x 2 pi over 3. Nope, pi over 3. So I'm substituting in my x and y. If I subtract 1 from both sides, I get 3 equals. And then if I divide both sides by this 3, I get 1 equals. So I have 1 equals sine of this thing. You're with me? Okay. We haven't really solved equations like this, but what angle has a sine of 1? You should know. And I like that when I look out there, everybody's doing this. You're visualizing this. It's pi over 2, right? This must be pi over 2. 3 times pi over 3 minus c has to be pi over 2. So I'm going to divide both sides by 3 now and get pi over 6 equals pi over 3 minus c, and I can solve for c. C will be equal to pi over 3 minus pi over 6. I need a common denominator here of 6, so I'm going to multiply the top and the bottom of this by 2. I end up with 2 pi over 6 minus pi over 6. And 2 pi over 6 minus pi over 6 is pi over 6. Didn't we get c as pi over 6? So there's an algebraic way to do it. And it would work no matter which of those points you choose. Okay? You're still going to end up with sine of the angle equals 1 or 0. All right. I just want to see where we're at. One last one here. This is going to be a cosine function. It's the same graph. I hope everybody understands that if we said a was 3 for a sine function, a is still 3 for this. And d is still 1. And b is still 3. None of that changes. It still repeats every 2 pi over 3, so b is 3. It still has an amplitude of 3, so a is 3. The midline vertically of the graph is still at 1, so d is still 1. The only thing that changes is this. This is a cosine graph. And cosine starts at the top going down. Now, do you agree we could solve this problem very easily by just reflecting it? But we can't because a is greater than 0. They've slammed the door on us in that venture. We can't just do that. So what we say, if you want to do this visually, which will work here, you can say, what do I need to do to this green graph to get the graph I want? And the answer is I have to shift it pi over 3 to the right, which means c is pi over 3. Yeah.
Would it be plus or minus because you could also go to the left?
Yeah. And sooner or later, somebody always brings that up. I'm glad you did. In fact, there's an infinite number. And I want to go back to this for a second. I could have, I want to draw in that start point before the shift was here going up. I could have shifted pi over 6 to the right, or I could have shifted pi over 2 to the left, right? And you're following along. I get this. I get that you understand it, so I want to use this as an opportunity to explain it to everybody. Usually, a question on an exam will say, with a minimum possible phase shift, in which case we would do this and not negative pi over 2. But if you use negative pi over 2 and you put x plus pi over 2 at the bottom here, and you graph them both on a graphing calculator, they're the same graph. Okay? When we get to this one, what Riley is pointing out is I can shift this pi over 3 to the right to get the graph I want, or to get the graph I want, which is here, I could shift it pi over 3 to the left. And now we run into a problem because if the exam said with a minimum possible phase shift, they're both the same. However, in that case, what they would say, Riley, is with the minimum positive phase shift, what is the equation? And then you would go with pi over 3. And, you know, going back to the possibility of getting multiple equations, of course, if we were allowed to use a negative a, there's a third equation. These would all be the same graphs. So yes, it is plus or minus. Just given the context of this question, there would be nothing wrong with you writing this. or writing this or, I mean, you need to be adaptable in this. This is Math 30. You could write this equation this way. Right? And that, on a multiple choice, that can be a real fooler for you. Because you would look at this and you might make the mistake looking here and say, oh, well, that's a phase shift of pi, and that's wrong. But what's happened is I have multiplied that 3 back in. Good morning. I've multiplied that 3 back in just to clean it up a bit. It's like the opposite of what we did in one of the earlier examples where we had to factor a 3 out. I think it was even a 3, and it was even a pi. So anyway, either of these are acceptable, but if it did say with a minimum positive phase shift, then you would be talking about this equation here. Thanks for pointing that out. Any other questions with that example? Just to show something to you briefly here, and you're going to get this. This is an example, just like the one we did, except, and I'm not going to do it because it's part of your review, and you're told that A is positive. If you said, and this would be really, really difficult to wrap your head around, doing it visually. If you said, well, the maximum is at 3, the minimum is at negative 13. I don't know how well I drew that to scale. The middle would be at negative 5. If you think about the numbers, from negative 13 to 3 is 16. Half of that is 8. In other words, the amplitude is 8. So 8 below the top or 8 above the bottom is where the middle of this is. So, that's at... I didn't draw it perfectly to scale, but this is at negative 5. It doesn't matter. So the problem here is this. If you do it visually and try to find C, you say sine starts here going up. How on earth are you going to figure out how much to shift that to the right? You can't. What you need to do is put in your amplitude of 8, sine of... Well, you would figure out what B is, and I'm just going to do this quickly for you. It turns out that B is a half. X minus C plus D, which is negative 5. So the only way, if you think you can find out what C is by looking at that, good luck, and I applaud you if you can do it. I don't even know where to begin. However, you can put in 3 for y, 5 pi over 3 for x, and rearrange it. By the way, when you put 3 here and you add 5, you get 8. What do you get when you divide by that 8? 1. You'll always get 1 or 0. And that will allow you to locate the angle that 1/2 times x, that 1/2 times 5 pi minus 3 over 3 minus c is. So you're going to see problems like that. Get to work, please, on these problems. And I'm going to hand out the review package for you. And some of you might choose to get a jump on that for next week.